This is the application which is deployed. I've exposed it to the outside world. Some random game, right? It's a 2048 tile game. It's pretty popular, right? Now I've deployed it and have multiple replicas and I've exposed it to the outside world. Of course, we don't share the IP address and the port number to the end users. We all know before we deploy our application to the outside world, you need to put them behind a DNS server. You need to run a web proxy at port 80. That's what we do, right? So if you don't really give the IP addresses, you don't expect your end users to remember the IP address and port number. Well, those are the additional steps what you need to do when you deploy your applications to production. That's outside the scope of Kubernetes for now. Well, the point is this application is exposed, assuming we have some URL set here, some DNS name, and now I have 5 copies of it, and there are 1,000+ users accessing this game. And suddenly this game becomes viral, pretty popular, and now millions of users start accessing it. What's going to happen? Well, what's going to happen is this one guy, this for replicas are not enough. Not enough per se is maybe a million users are accessing 5 copies of them are able to take over the load. But the game becomes viral and now hundreds of users, millions and thousands of users are accessing it. These guys are going to get back down. So what do I need to do? Well, I need to add more copies, increase the replicas. And so far, whatever we have learned, the replicas, what we did was scaling up manually. 2 o'clock in the night, there's sudden surge. You don't expect me to log in and increase the count of replicas. What can we do? Well, Kubernetes has a solution for you, and that's called as Horizontal Pod Autoscaler, HPA as we call it in short, Horizontal Pod Autoscaler. What does this guy do? Well, we create another controller which sits on top of any any controller which you can scale. You hand over the scaling part to that. I've copied this from the documentation. So you create another controller called as HPA, and you give the scaling behavior of that particular replica set or deployment to HPA. The HPA sits on top of the deployment, keeps an eye. Of course, you need to tell that as part of your desired state, when to scale, what to scale, and stuff like that. So what do you need to mention? You need to mention a few things to HPA. So you're asking somebody else to keep an eye and scale, but somebody else is HPA in our case, right? So when you create the HPA, first thing you tell is there can be hundreds of deployments out there in your cluster. So you need to give which deployment am I talking about. You need to give a scale, a target reference, telling that there is a deployment called as game. That is what I'm talking to you about. Keep an eye on this guy. Fine, I'm going to keep an eye on that guy. Then when do I scale? What is the trigger point for me? You want me to add some replicas, increase when the load increases, correct? So you need to give me some threshold. What threshold? Well, until the version 1.22, the only option, the HPA, what was in the version V1 of the API resource there, it had only one field called as target CPU utilization. The CPU utilization of the pods combined, of all the pods combined of this deployment, is going to take that into consideration. Default is 80%. When the CPU utilization goes above 80% of these pods, that means CPU utilization is directly proportional to the number of requests what your application pod is handling. Right now, if I go look at the CPU utilization, maybe it's 0 because there's no requests at all. So if you have millions of users accessing and millions of requests, there's a lot of context switching, your CPU utilization goes up, right? So you give that as part of your desired state when you create a HPA. You tell, listen, at this particular threshold, maybe 50% when the CPU utilization goes above 50%. Scale up and do what? Well, scale up and add more replicas. Now, I've mentioned the threshold as 50%. So as long as the CPU utilization of all the pods which is being managed by this deployment is under 50%, the HPA is not going to do anything. This is my desired state. Till 50%, you don't need to do anything. If it breaches 50%, maybe it goes to 60, maybe it goes to 70. You need to do what? You need to start adding more pods. You need to start adding more pods and then collectively try to bring down the CPU utilization to below 50. Say, for example, if I had only one pod and then the CPU utilization went to maybe 80, right? So if there's an algorithm though, I'll go show that algorithm to you. That the algorithm is your current metric value divided by desired metric. Current is 80, desired is maybe 40, for example. For division purpose, if I keep it simple, it's going to show you as 2. So 2 is the number of replicas what you need to add, so that if the CPU utilization goes to 80 and if there's only one pod replica there, if you add 2 of them, the load can get distributed, the CPU utilization to come down to 40. There's an algorithm, we'll look at that, but the point is you need to, whatever you need to do, how many ever replicas you need to add them to bring the desired threshold to whatever I have. So if it gone to 70, 80, 90, meaning that number of pods what we have is not able to handle this load, bring it down to 50. So bring it down to 50, what do you need to do? You need to start adding more pods, meaning scale up, right? And now I do not, say for example, if you have a denial of a service kind of attack, where you're constantly being bombarded and constantly being hit, that threshold is going to go off. No matter how many pods you keep on adding, the CPU utilization is not going to come down to your threshold. So I want you to scale up, but I don't want you to infinitely scale up and max out my cluster resources. So what I do is I give the upper limit as well. That's called the max. I want you to scale up, keep on adding pods, 1, 2, 3, 4, 5, 6, 7, 8, whatever pods you want to bring that threshold to my desired value. But for some reason, you can't bring it down. Don't infinitely keep scaling up. I know my application, it does not need to go up beyond 10 replicas max. So I give a upper limit. It tries to scale up from whatever count you have to the max value. And if even beyond max, it's not able to bring it down to the threshold, it is going to ignore it. Similarly, when everything is fine and there is no, everything is beyond the threshold, what is the minimum number of replicas I want you to manage? I will set that to minimum number. Maybe I will set it to 2. So at any given point of time, I want 2 copies. When the threshold is under 0 or 0 to 50, keep the minimum count. So the scaling part, I will hand over to another controller called as HPA, and I give these 4 options to him. He's going to look at that, which deployment, what threshold, and it's going to scale up gradually, try to add more pods to bring it to the desired level. If it is not able to do that, it will stop at the max level. When everything is fine, it will maintain the minimum replicas what you've asked for. That's your HPA. That's how you're going to create another controller called as Horizontal Pod Autoscaler. Let's go take a look at that. But one thing is, for HPA to work, it needs to have some metric value. The metric value here is the CPU utilization. So how can I get that metric value? That opens up another question, is what kind of monitoring do I have available out of the box in the Kubernetes cluster what I have set up right now? The answer for that question is I do not have any monitoring going on right now, because when you make use of kubeadm to set up your cluster, there's no monitoring involved. There's monitoring needs to be an additional item on top of it. Kubernetes supports various different tools per se. There is a metric server, a very lightweight application which can monitor the 2 basic resources you have, in memory and CPU. But again, that is not installed or deployed by default. You need to deploy it. Or there are other tools very quite popular. There's Prometheus, which is very popular. You need to, again, it's not installed by default when you set up kubeadm cluster. You need to add on, create a deployment, create Prometheus as a deployment, and then you need to enable monitoring on top of it. How you can make use of Elastic Stack. There are paid versions like Datadog, Dynatrace. There are many of them available, and Kubernetes has support for all of them. There are images of those available. Few of them are open source. Few of them are paid versions like Datadog and stuff like that. You can set them up. But there is a monitoring server which is available for you. Of course, it is not deployed by default, but there is a monitoring server called as metric server. So every that kubelet which is running on every node of your cluster has a subcomponent called as cAdvisor. cAdvisor stands for Container Advisor. It's an open source tool. When you're running standalone Docker, you can also install that. What does this guy do? This guy captures your CPU and memory utilization, 2 basic requirements. There's a metric server. It's a thin, very thin, lightweight in-memory kind of an application, which is provided to you by Kubernetes. You can make use of that. It's not deployed by default. You can deploy it. It's going to talk to your kubelet on every node, and it's going to capture the memory and CPU. This metric server is not stateful, meaning it does not store anything on the database. It does not tell you what was the CPU utilization 20 days ago. It's not going to tell you all of that. It's going to show you what the current memory and CPU utilization is. So you need to have for HPA to work. It needs the metrics. For metrics to be running, you need to have some monitoring going on there. So you need to have the metric server installed. We need to do that right now, which is not installed in my machine right now. So there's another command called as kubectl top that also makes use of your metric server. So if I say kubectl top and show me the CPU and memory of the nodes available out there, it's going to come back to you and complain that metrics API is not available. So if I take you to the documentation, and if you look at metrics server, it tells you can, metrics server fetches metrics from kubelets and exposes via metrics API. A kubectl top command can work with it. It tells you it is not installed by default. You can do so by visiting the GitHub and downloading it. There's a URL here. It talks about what metrics server. It tells you it is very resource efficient, takes only 1 millicore of your CPU, 2 MB of your memory, and what it does, it collects metrics every 15 seconds and support up to 5,000 nodes in a cluster. And you can just deploy it this way, and your metric server will be installed. So right now, when I came back and I did the kubectl top node, it says metrics API not available because the metric server is not deployed. Let's go ahead and deploy the metric server real quick. Copy the same YAML file what we saw in the documentation, and it deployed something. If I quickly go back and do kubectl get pods in the namespace kube system, we see the metric server is in the container creating stage. We can also do -watch. It's currently running but not ready. It's going to come back in the ready state in some time. But anyway, the point is we've deployed the metric server. Now when I go back and I do kubectl top nodes, now it does not tell you metrics API not available like the way it did earlier. Now it's telling you some other error because the metric server is still not up yet. It's still not come to the ready state to accept the traffic. And once it comes up, it's going to take 15 seconds to go scrape the metrics. Now kubectl top command is working because we have installed the metric server. Good. Now, this is also another important interview question, not interview, the exam question as well. So this top command works with respect to the nodes, the pods, and the container level as well. So I can do kubectl top pods as well. So it's going to show you at the pod level, the memory and CPU, right? And if I have multiple containers, like for example, top pods -n cube -system. So for example, ViewNet has multiple containers, has 2 containers in it. So if I want to look at the container level, it's going to show you that value at the container level as well. Like in the pod, I have multiple containers. I want to look at the CPU memory utilization at the container level. You can. You want to look at the pod level. You can. You want to look at the node level. You can. So the top command shows you nodes and pods. All right. Additionally, it also has option like sort by. I can do -sort -by equals to MEMORY. It's going to sort them. Why are you showing all this stuff? Well, like I told you, the exam is going to be a combination of questions which take less time and questions which take larger time. There can be a simple question that says, hey, okay, listen, in this namespace, there are 20 pods running. Can you tell me which pod is consuming highest number of how much highest memory? So for example, if you run the top command on the namespace, maybe everything looks something like this. Everything showing as 15, 18, 15, 19, 16. When you look at it with the naked eye, everything looks the same for you. So in scenarios like that, if you have a question, there can be a question out there. You can just do sort by memory, or if the question's around CPU, you can sort by CPU. It's going to sort it out for you. Here, of course, 234 is right up top. We can identify. If there's a question, if I ask you a question, which is the pod in this particular namespace consuming highest number of CPU or memory, your answer is this question, this pod name. So you need to take the pod name and write that pod name as the answer to that question. So that from that point of view, top command is what I showed you a little bit in depth, but we came here looking for the HPA. All right, let's go and look at the HPA. For HPA to work, I need to have the metrics, and we install the metrics. Good. Let me quickly clean things up. Kubectl delete. Let's go look at the HPA right now. So for HPA to work, what do we need? We need a deployment to be created. Let me quickly get the deployment YAML. We're going to create a YAML file deployment. Kubectl apply from file web app.yaml. We've created a deployment. Let me open the deployment. Let's look at the deployment. I'm going to delete few lines here. This is the Regular deployment, what we have seen so far, correct? We have spec, we have replicas, we have selector, and we have template, right? The regular deployment. So let me undo the lines what I deleted. Now we're getting introduced to a new concept. New concept of what? Of resources. So optionally, you can specify resources what your container needs. Most common resources what you have are CPU and memory. I have seen this somewhere. Yes. Let me save this. Let me go back to the Docker world. When I was running the container, Docker container run, ask for help, we made use of something. What? Hyphen hyphen memory. Remember? By default, your container can consume as much as memory available on the node. By design, we don't want that to happen. Why? There's a badly written code, there's a memory leak, there's an attacker who got access to the container, he's gobbling up all the memory of that container. Well, that container is going to consume all the memory on the node. The other containers, other processes on the server are going to starve. We don't want that. We understand our application. We know our application does not need a memory certain beyond a certain limit. So when we ran our containers, we made use of hyphen hyphen memory or hyphen m as an option, and we set the upper limit. So beyond this limit, your container could not make use of the memory. What happened when it hits the limit? Well, based on how you have defined your application, maybe out of memory exception and stuff like that. Similar, you had something else, hyphen hyphen CPU, where you could define how much of CPU your containers can make use of. By default, they can make use of as much as a CPU available on your host, right? That's when you ran your containers, specify some options with memory. You had the memory soft limit as well. Reservation, that amount of memory will be reserved for you. Now back to the Kubernetes world. Same containers are what we're running. So far what we ran without any limits. So now the way you restrict that CPU and memory in the Kubernetes world by another keyword under your container spec. Under your, not under your pod spec, under your container spec. You see under your spec containers is where you have, because you need to specify these limits at every container level, right? So we have two ways of doing it. We have resources, we have under resources limits and request. And there are two resources. There is your MEMORY colon in double quotes. Memory is represented in bytes, kilobytes, megabytes, gigabytes, and CPU is in millicores. And again, it is also M here. Well, memory we understand is in bytes, kilobytes, megabytes, gigabytes, right? CPU resource units are called as cores. One physical CPU or one virtual CPU is 1024 millicores. Well, here M here stands for millicores. That means if I had one CPU, 100 milli is nothing but 10% of CPU. So this particular container can't see beyond 10% of CPU, meaning the 10% of my CPU of that host is equivalent to 100% CPU for this container. CPU is in cores, memory is in bytes. We understand that resource units concept. I'm not going to deep dive on that, right? So there are two ways of defining it. What? Under resources, you have limits, you have requests. What are these two? Well, first, let's look at the request. So when you specify resource request for a container in a pod, this information is used by two people. First, it is used by Kube scheduler. So far, the scheduler was doing whatever it was doing, right? We never told my scheduler to do what we wanted to do. We are getting introduced to certain things where I'm telling my scheduler, listen, dude, put me onto any node. I don't care. As long as that node has this much amount of memory for me or this much amount of CPU for me. So scheduler makes use of this information to decide which node to place you on. So it's going to look at the hundreds of nodes what you have. It's going to search for the nodes which has at least this much of resource what you have asked for is available there. It becomes like a filtering criteria for your scheduler. Of course, if the 100 nodes, 500 and after 150 nodes are having this capacity, it's going to filter those 50 and it's going to rank and score and choose any one of them based on which gets the highest ranking. But I gave the filtering condition, that's your request. That's point number one. Scheduler makes use of this information. Good. And whatever you've mentioned under the limits, that's your upper limit. Your container can't make use of beyond this. Kubelet on that particular node is going to enforce this limit. So your container can't see beyond this. What happens? Well, what happens if you're running your application and your CPU reaches 100%? It's stuck there, right? Same story. Memory, same story. Gets killed usually with out of memory exception, OAM, right? Limit is enforced by kubelet and your container is not allowed to use beyond what is the limit. Request is made use of by two guys. First guy is the kube scheduler, which uses his information to decide which node to put you on. And then what it does when it goes to a particular node, kubelet what it does also reserves the requested amount of that resource for especially for your use only, for your container use. It's going to do a soft reservation out there. That is your request. So I'm going to undo what I've added. Here in the HPA, I kind of introduced you to this concept to show you the scaling part, because by default, that container can consume as much of resources. I can't add that much load to scale up automatically, but we wanted to introduce you a new concept. How do you restrict your limits and how do you do soft reservations? And you tell your scheduler where to put you is with the help of resources under your containers. Under resources, you say limits and requests. There are two kind of resources, your memory and CPU. Memory in bytes and CPU in your cores. All right, but we came here to look for HPA as a concept, and we got introduced to something else, something new. Good. So I'm going to create this deployment right now. I think we did already created this. Get all. So we've created a deployment which has 3 replicas, and that requests what we have said. Right, life is good. Fine. I need to create a service for this to access it. Good. So what do? We learn the expose command. Very easy to create a service. We'll say kubectl expose a service, a deployment. What is the name of your deployment? Here's the name of my deployment. And what is the port number for my service? Well, whatever I want. What is the name of the service? If you don't mention this option, the name of deployment will be the name of your service. I will say create me a service, whatever name, right? And I will say maybe create me a type is equal to node port, because we have learned that. Of course, I can do expose and help. It shows me all the options. I'm just showing you a few. Easily, I was able to create a service. Good. Now, kubectl get all. We also have a service node port created. This is the port number what has been given to me. Good. So if I say in my etc host files, I've added kube node 1 as an entry, and if I say this port number, I'm able to access that application. Fine. Now we need to see the HPA. Let's create the HPA for this guy. Let me download the YAML file for my HPA. Kind as Horizontal Pod Autoscaler. The group belongs to autoscaling. The version is V1. In the new versions, of the Kubernetes at 1.23 onwards, 2.3, 2.4, 2.5, the version of autoscaler has been upgraded to V2. V2 has more options what you can specify. V1, there's only one option what you have called as target CPU utilization percentage. Well, under the HPA spec, there are 4 things, which is the target reference. Hundreds of deployments, which deployment you want me to scale up? Well, there is a deployment which belongs to apps as a group version V1, name of this guy. This is what I want you to keep an eye on. I'm telling my HPA, and I'm telling what is the CPU utilization. Default is 80%. And I want the scale up to happen faster. I've mentioned 20 as my default. So it needs to ensure at any given point of time, the CPU utilization of those pods out there collectively is below 20%. So do whatever you need to do. Add as many as replicas as you want to bring it down to below 20%. But I don't want you to max out my cluster resources. I don't want you to infinitely scale. Maximum you can scale up to 10. Beyond that, well, don't do anything. I know my applications max 10 should be enough. When it is all under 20, under the threshold, life is good. I want you to maintain minimum of 2 replicas. I've mentioned that. I'm going to create my HPA. kubectl apply from file hpa.yaml. My HPA got created. Very nice. kubectl get all. And I have HPA also created here. That HPA is referencing a deployment name as web application. And right now it's telling I don't know what is the current CPU utilization, because when you deploy an HPA, HPA is going to go scrape your metrics. You already have exposed your metrics API, you have installed your metrics API server, and it's going to scrape this metrics every 15 seconds. Can we change all of that? Of course, we can change all of that behavior. Default is 15 seconds. You don't want it to keep on scraping your metrics and slow down things. That's why the default value is set to 15 seconds. So it's going to take some time, like 15 seconds. If we come back and look at it, now it has captured what is your current metric value. Now these pods of this deployment currently are consuming 0% of CPU. Nobody's accessing it. So we need to do what? Add some load. How do I do that? I need to access that application, correct? So what will we do? We will make use of a tool called as Siege. It's a third-party tool. I'm going to run that, and I've installed a tool called as Siege. It's a regular tool, general load testing tool, HTTP-based load tester that is, and just to add some tool load out there. So if I quickly do kubectl get all, This is the port number what I have, correct? So what do I do? If I make use of the tool what we have installed called as Siege, and I say concurrently, is the quiet mode, don't give me any verbose output. Concurrently as 5 users for the time of 2 minutes. I want you to hit this URL. That URL is cube-node1 and the port number. Any node name, node IP you can make use of. I can make use of my node name because I've added that IP address in my etc host file. Otherwise, you can make use of node IP. You can internally, I can in the cluster, I can make use of cluster IP and this port number, node name, node IP, and this port number as well. So what's going to happen is going to hit this URL for 2 minutes straight as 5 concurrent users. The moment you hit this, what's going to happen? It's going to say welcome to Nginx, 200 response, right? And maybe it takes a milliseconds, and then it's going to again going to bombard it with the same request. So it's going to do in this 2 minutes maybe a couple of thousands of transactions. So in a way, what happens? All of my pods are going to get busy. The CPU utilization of those guys is going to go up. We have capped the CPU utilization. Little bit of CPU spike there, that's going to cross the threshold of 20%, and it will see the scaling up happening. Let me hit enter. Siege right now is running. Let me come back to other screen. What we have? This matrix is scraped every 15 seconds. Right now, it is showing as 0%. So after 15 seconds, it's going to come back and go look at the metrics. Now that we are bombarding it, constantly hitting this guy, the CPU utilization is going to go up slowly. You see the CPU went up to 18% right now. Still not enough to trigger the scale up. Beyond, it's still below 20%. Still, it's not going to do anything. It's still going to maintain the same replicas. So we're still constantly hitting it. And now we see this metrics jump to 36%. So it needs to add more pods to bring it to 20%. So it realized I need to add 3 more replicas or 4 more replicas. You see 4 more replicas were scaled up.
Now, we are going to discuss one important point, which is requests and limits. We have already discussed that how we can, impose requests and how we can impose limits to the pod. If you limits and requests in Kubernetes, and if you check the Kubernetes documentation, you will notice that we have, the implementation of requests and limits for CPU and memory. These are the two major resources that we generally discuss, right? So, and this is how we implement these limits. But do you really think that when you start creating the pods or when you start creating the deployments, do we really care about these limits and requests? Of course, we don't, right? So as a developer, it is rather our secondary responsibility to implement these requests and limits, although it is always recommended to do so. But administrator or the Kubernetes administrator has the responsibility to ensure that by default these requests and limits are get attached to the default deployments that we are creating in the Kubernetes. Why? It provides more control, right? We need to ensure that the deployments, the pods that are getting created, they are not eating up all the resources of the node. Okay. So in order to ensure that, we have something called as limit ranges. What is a limit range? Limit range is nothing but the implementation of default. Okay, so I'm going to create a diagram here. So limit range. What is a limit range? Limit range is basically a setup which is applied by default in a namespace. So remember the point, it is implemented at the namespace level. And the idea is that we set the default requests and default limits for the pod that are getting created in a particular namespace. So let's take an example that you are working as a Kubernetes administrator. a development team comes to you and says, hey, you know what? We want to create our pods, create our containers in the Kubernetes cluster, and we want you to give us the namespace. So, what we have earlier seen, we just create a namespace called kubectl create ns, and we create a namespace maybe with the name of development. Now, we really want to make sure that even if those guys don't put any kind of limits for our pods or for our resources or for our objects, eventually those limits get added to the container. So how we can ensure that? So for that, system administrator can create an object called limit range within that namespace. He can create a limit range of, four ways. He can ensure that there is some kind of minimum, resources that can be allocated to the container. Then we have default request. Default request is nothing but a kind of request which, if you don't give any request parameter, if you don't give any request parameter, that much default requested value, whatever you have defined in this particular limit range, get attached to your pod. Now we are talking about control here, right? So what is the default? This is the minimum that you should give. This is the default which will be implemented as a request. Now this is a default value which says that, hey, if you want to put a limit, by default, this is the value that will be attached to the containers that you will create. And then lastly, we have something called as maximum. So in limit range, we define these four values and they must be in order. Why? Because you know that if you are giving the resources, CPU or memory by yourself, you can give this much minimum, resources to a particular pod. If you don't give any request, this will be the one which will be allocated. For example, let's take an example here. So I'm considering an example which we have already discussed, that there is a development team and they want us to make sure that we can create containers in a particular namespace. So we are going to define a minimum value for our memory, and we are going to say, hey, you know what? Just create minimum of 200 megabytes. And you can do the same for CPU, that, okay, minimum 50 millicore will be attached to the particular container. Then comes the default request. Now, default request should be greater than or equal to what we have defined in the minimum. So here I am considering that 250, I'm just giving a slightly upper limit as a default request that will be attached to the pods. And then similarly for CPU, we are going to consider it 100 millicore. Similarly, what is the default limit that will be attached? So by default, let's say 300 maybe bytes, and let's say 200 or 300, whatever, will be given as a limit to the pods or the containers that will be created within the namespace. And likewise, what is the maximum that you can give by yourself? This value and this value. If you are providing, then these values should be respected. If you are not providing anything, then this and this will be the request and limit respectively. So likewise, the memory can be up to 400 megabytes, and of course, let's say the CPU that you can provide for a particular container is 500 MB. Now this creates a control mechanism in your particular namespace. Okay. So in order to do so, you have to create a limit range in a particular namespace. We will see this in action in a while. But for now, I'm considering that the limit range is something which is basically attached to a namespace, right? I discussed that, okay, I'm going to create one namespace where I'm going to create a limit range. So basically, limit range is a namespaced object. Similarly, there is one another component which will ensure that you are not overcommitting the resources by creating hundreds and thousands of resources. And what is that component? That component is called resource quota. These two components go hand in hand. So this is more specifically for containers, and this resource quota is for all the resources that you basically create in a particular namespace. Okay. So resource quota says that, hey, you know what? I really want to limit the CPU. I really want to limit the requested value that this particular, namespace can have. I really want to limit the total number of replica sets that can be created. I really want to limit the total number of pods that can be created within this particular namespace. So here I am limiting the resources. What are the resources that I can create? I can create replica sets. I can create pods. I can create deployments. Now, there are many other components that we have not seen. But based on these, resources, you can identify that basically resource quota can be applied to any object which is there in the namespace. Any namespaced object can be given a limit that in a particular namespace, these are the limits that get attached. So, for example, I can say you should not have more than 2 replica sets. You should not have more than 10 pods in one namespace, and you should not have more than 5 deployments. So if the replica set is there, I'm imagining it should have the same value as replica sets, right? That's only it makes sense. Okay. So these kind of limits, when you apply it in the namespace, we call it resource quota. And why we are learning this? So that we have a control over the namespace. We can control the namespace. Nobody is creating endless resources there, and nobody is, overcommitting the resources that they might not use within the container or within the namespace. Does it make sense to you guys? If yes, let's see these things in action. So this is my master node. I just created the cluster. So now we have a cluster, kubectl get nodes. Let me see. Okay. So I have one master and one worker node set up. Okay. And what I'm going to do, I'm just going to create a namespace, kubectl create namespace with the namespace test. Okay. Now I want to set these limits, okay, here. So in order to set these limits, I just have to first, or, I can use any one of them, or I can apply both of them. It's up to me because they are serving different purpose. This one will be applied to the containers, and this one will be applied to all the namespaced objects. Okay, so I'm going to create a component called limit range. Let me see. Okay, so limit range.yml, and let me just take the example of limit range from here. So you see here, we are saying that for the type of, for which type do you want to put this limit? You want to put this limit for containers, right? Generally, we have one container per pod. We might have more, but for now, we are considering that we have one container per pod. Okay, so what is the default value that will be allocated? The default value which will be allocated is For CPU, it's 500 millicore. And similarly, for the request, it is 500 millicore as well. This is the default. If you don't provide anything, this will be the, request that get attached to the containers. Okay, so let's see it in action. So if I'm going to create this particular limit range, and I really want to create it in my namespace called test. So I will put the namespace section here as test, that so that it gets created there. And similarly, I will create pod. I will see that if I try to give the requested value, which is more than the default requested value, and it's less than what we can have, will it allow it or not? We will be able to see that particular thing. Okay, so I'm going to say pod.yaml. And of course, I really want to make sure that the namespace is added. So just in case I forget, the object get created in the right namespace. Okay. Now I have the limit range. Okay. For the CPU, where the default is this section defines the limit. This is the limit of my default, which will be created. And similarly, for the request, this will be the value that will be allocated. Now, look this particular point carefully. If you see the pod, I am saying that this is the default requested value that we should have. Okay. And what is the request that I am putting up here? The request that I'm putting up here is 700 millicore. And what is the minimum? And you see all the values here. Maximum is 1 CPU. So this is in order what we discussed here. Okay, if you look carefully, although they are placed in different order, but they follow the same order, that minimum should be the lowest value, maximum should be the highest value at the very right. Then we should have the default requested and the default limit, right? This is how it should stretch itself. That's how it should be, right? Okay, so now let me kubectl apply -f, and then I'm going to create a limit range. Okay, and now I'm going to apply the pod. And you will notice that right away it has given me an error that, hey, this is an invalid value for the request. Why? Because it must be less than or equal to the CPU limit that you have defined. And that makes sense, because if you cross the requested value, which is higher than the limit value, it does not make sense. So you want to reduce that value. And now let's make it minimum. So here I am going to make it minimum to 10. And now again, if you notice, what should be the minimum? Yeah, what should be the minimum CPU? It's 100 millicore. Let me try with 10. Oops. It's again saying that, hey, it is not allowed. When you are creating pod, this is forbidden. The minimum CPU usage per container is defined as 100 millicore, but you have requested 10 MB, 10 millicore. I cannot allow you that. Now, how do I identify as a developer, if let's suppose there is an administrator who has placed these limit ranges for my setup, I will be really pissed off. But there is generally a contract between an administrator and a developer to have these values defined. And you can check it with the help of kubectl get limit range. Okay, so I have to check it for the namespace called test. And you can see here that this is the limit range that we have created. And if I do kubectl describe limit range in the namespace, as always, you can see here that It is telling me that, hey, for container type, you should have a resource CPU, a minimum of 100 millicore, maximum of 1 vCPU. Default value should be this, and default limit should be this. Now, if I get frustrated, what I can simply do, I can simply go to the pod.yaml and I can remove these requests. And what is going to happen? It gets created. kubectl get pods in the test namespace, and kubectl describe pod. This is the name of the pod, and in the namespace test. And you will notice that the quality of class, quality of service class, earlier it used to happen as a best effort. Now it is burstable. Why? Because we have created the limits, whatever was given in the limit range, whatever the default value, the limit and requested value get attached by default. So now, if you try to increase this particular limit, it will not go beyond, or it will not go beyond the minimum. And that's how you will control a particular container utilizing too many resources. Okay. Now, is that enough? No, definitely not. We need one more control, which is called resource quota. And let me see how the resource quota works. Quota. Whenever you study some, I always show you the Kubernetes documentation, because that's the best explanation, best documentation that I have ever seen. Okay. And if you notice here, look at these components. So you can set the quota for total number of a particular kind of resource that we have in Kubernetes. Persistent volume claim. It's a namespace entity, services, secrets, config maps. We have not seen all that. Replication controller, old way of deployment. So we have not seen that as well. Deployments, replica sets, stateful sets, jobs, cron jobs. So there are many components that we have not seen. But you can see that we can, limit the count. And not only that, you can limit the request and resources of CPU and memory. How to do that? This is how you can do that. You are going to put CPU limit. You're going to put the memory limit. You can, across all the pods, these, CPU requests should not cross. The requests of the CPU should not cross this much, whatever you value put here. Whatever you value put here in the request.memory, that much requested memory should not cross beyond that. So you're defining that, okay, your request.memory should not cross 2 GB, but your limit.memory can go up to 3 GB. That's how you can decide. But you are putting the upper limit for each and every resource. And that's what we do in case of resource quota. Okay. So now let's create a resource quota. And I'm going to, okay, so I will give you one command which can really help you out. kubectl create resource quota, or quota, so to say, if I'm not wrong. Okay. Yeah. You see, you can create quota or resource quota. It's the alias. You can see here, quota and resource quota, one of the same thing. And you can decide, hey, you know what? For this particular namespace, I don't want to go beyond 1 CPU. I don't want to go beyond 1 GB of memory. I don't want to go beyond 2 pods. I don't want to go beyond 3 services. I really don't want to go beyond 1 resource quotas. So quota is setting up the limit for resource quotas. So I should not have 2 quotas at a time. I mean, based on this example, right? And then I should not have more than 5 secrets, etc., etc. I'm creating a resource quota. You want to create this, you can create this, or again, like always, I always love the examples that are given here. And you can see that there is a kind called resource quota. Okay, so you see, this is the resource quota. and you look at the hard values, CPU 5, memory whatever, pods whatever, and there are some another scope selectors. Don't pay attention to that. It's a little advanced section. But for now, understand resource quota as the limits. Let's put them. Let's apply them and see how it works. So I'm going to say here, I already have test. So I'm going to create a quota. So kubectl create, let's say quota my quota. Okay. The hard limit is going to be, let's say that's it. Okay. In the namespace test, and my quota is created. So if I do kubectl get resource quota in the test namespace, you will see that I have the quota implemented 10 seconds ago. Now, you look at the values here. It is telling me that I have, requested for CPU, which has a higher limit of 1. How much has already been used? 500 MB has already been used. I have allocated 1 GB. How much memory has already been used? 0, because there is no activity in my pod. Similarly, how many pods limit I have taken? I have taken pods as, as 2 as a limit. So I have created 1 pod already. Kubectl get pods hyphen o, oh, sorry, hyphen n, and test. I will see that I have 1 pod running. Now I really want to delete it. Okay. Kubectl delete pod, and I'm going to delete the pod. Now let me create a deployment and let me see what happens if I create a default deployment. So again, I will go to my basic structuring. I will pick up this, and I have 3 replicas here. So that's why I'm picking it up. Okay, guys. Now look at what is going to happen. Deployment.yaml. And so I really want the deployment to happen in the namespace test. So that's what I'm putting. And let's start with 2 replicas, guys. Okay. And I will say kubectl apply -f deployment. Okay. Now look at the deployment. Kubectl get deployment in the namespace test. Oops, what happened? Nothing is getting created. Something is wrong. Let's see what is wrong. Kubectl describe deployment in the test namespace. And you can see here that we have not defined the replica sets, right? So let's see kubectl describe replica set. And I think first I will say kubectl get replica set in the namespace test. And you can see here it is desiring for 2 pods to be created. So the replica set was created, in fact. So, but if I describe this replica set, describe replica set in the namespace test, you will notice that, hey, you know what? Error in creating pod this much is forbidden because it failed quota, and you must specify the memory for nginx. You have not specified how much memory it is going to take. Okay. And now what I'm going to do, I'm going to make sure that whatever is, it was 500 MB. If I am not wrong, I will check it again. Kubectl is kubectl disk get limit range in the test namespace. Okay. And I will try to kubectl describe the limit range in the test namespace. And I'm going to put 500 MB. Okay, so that it matches and does not get conflicts with my resources. Okay, so I'm going to go to my deployment, and of course, I have to make sure that I have the proper requests. So I'm going to go within my containers, And within my containers, I will go to my images, and here with images, I'm going to say, hey, I want to apply the resources, and let's say memory. Memory is going to be 500 MB, and let's say the CPU is supposed to be default CPU. I have this is my CPU itself. I'm sorry, guys. So let's say this is 500 MI, okay, and then I'm going to define the CPU as 500 millicore, okay. Now, I really want to make sure that it works, so I'm going to put it in double quotes so that I don't want to mess, okay. kubectl apply -f deployment. Something is wrong. Invalid value. What value is invalid? I really need to see resources. Okay, so let me just ensure that I'm using the right tuck. Just give me a second, guys. I will take the values from here. Resource. Okay. So limits and requests. I think I placed it right. Resources. I did not put the limit section. So resources, and I have to say requests. So indentation is very important, and of course the syntax is very important. Okay, so I just have defined the requested resources. I hope you know what mistake have I made. Now it got configured, and I will try to see the number of pods, that is created. So now look here carefully. So I think it was only one. Is it only one that I requested? No, I requested for two. And here is the perfect example. Let's see why it is saying that out of one, one is running. Okay. So we are going to again. So I'm just verifying what we have done here, because now I have applied the limit range and I have applied the resource quota, which are restricting, my pods to expand exponentially as per my requirements. I have to make sure that the necessary resources are given, but at the same time, I have to optimize the memory and CPU, which is as per the limit range and as per the quota. Okay, now I'm going to just describe the deployment, Nginx deployment in the test namespace. And you will see here that it said that, okay, they really want to scale it up to 2, but it got scaled from 2 to 1 for some reason. I don't know. So let's see what was the reason. kubectl get replica set -n in the test namespace. Now, here it is saying that there was 2 which was desired, but for somehow I was only able to make one available and one is ready to serve. Let me try to see kubectl describe replica set in the, of course, what is the name of the replica set, and in the test namespace. And again, you can see here that my quota got exceeded. Why? Because it is saying that the requested memory is 500 megabytes and used is 500, and it is limited to 1 GB. I am 500 plus 500 megabytes is crossing 1 GB. So now it's up to me. Okay. Either I request the administrator, hey, you know what? I really need 2 pods. I want you to increase my quota from 1 GB to maybe 2 GB. So the administrator will then, do its magic and ensure that the resources are, increased again. How to do that? kubectl get resource quota, and in the namespace test, kubectl edit resource quota or quota. It doesn't matter. Now I'm just going to edit it here. What is the memory that I really want to allocate? Let's say that I want to allocate 2 GB now for this namespace. As soon as I make it 2 GB, I just have to make sure that I'm recreating the deployment. Kubectl delete deployment and nginx hyphen deployment. Oops, in the namespace test. And that's why I don't use, this context, but we will see how, I'm currently I'm always creating this hyphen n just to say that, okay, I am using this namespace. I am using this namespace. But today we have a demo by the end where, we really don't need to do that again and again. Okay. So I deleted and I am applying again. And I think it's deployment.yml. And I hope this time I won't be having any problem in creating 2 pods. Okay, so that's how the resource quotas and limit ranges really plays an important role.